Aluminum is a great fuel. However, compared to gasoline, for example, aluminum will be more difficult to ignite, although the temperature after ignition can be high, and we also need to worry about how efficient we can burn that without losing. We also need to worry about how long the combustion can go and how efficient the combustion can be. So there are a lot of work in this field try to engineer the interface between aluminum and oxidizers to make it easier to ignite and combust. One of the direction is to bring the size to a nano size such that the surface area available for aluminum and oxidizer will be enhanced. However, we know that at the surface, aluminum is relatively a reactive metal. But still on the Earth, we see so many aluminum. The reason is that there is a native oxide layer at the surface of aluminum. And we know that when the size of a material shrinks to the nano size, the surface to volume ratio becomes larger and larger, which means that for nano-sized aluminum, the native oxide layer at the surface of aluminum would be quite large, and which reduces the active component of aluminum that we can use for combustion. So there is again a trade-off, how to make the aluminum particle easier to ignite and combust while maintaining the actual active content of that. So there are two main regions that we are conducting our research on. The first one is that how to engineer the surface of nanoparticles and make sure we can improve the combustion efficiency. On the other side is that if we are dealing with bulk materials, how we can engineer this interface between aluminum and oxidizers to make it more reactive. Or instead of directly burning aluminum, can we use aluminum as a fuel to react with water to generate hydrogen, and then we can directly utilize hydrogen as a fuel. There are two ways to utilize aluminum. One way is to directly burn that. The other way is to use aluminum and water to generate hydrogen gas. If we were to directly use aluminum on our vehicle, probably everyone would imagine yourself just riding on a rocket engine, on a solid rocket, and then you can go forward. Of course, it will be very challenging. So there will, and also how we can collect the components after the combustion will be really challenging. When we shoot a rocket into the space, we don't worry that much that we actually generate a lot of byproduct and just emit them into the space. However, we are on Earth. Definitely, we need to worry about how we can collect things. That is another reason why people are also interested in not directly burning aluminum, but to use aluminum to generate hydrogen, such that the byproduct will just be water and it's easy to collect. And even if you just emit it to the environment, it's not a bad thing.